Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on sampling. This is basically just a list of definitions that you need to know. So let's say I want to know something like the number of hours of maths homework completed. Well, I need to specify who am I asking, from whom am I going to get data. So I've decided to look at just Year 12 students in the ACT. The people I'm interested in, they comprise what's called the population. But you see, there are lots of Year 12 students in the ACT. It would be impractical for me to ask all of them. So instead of conducting a census where I ask everyone in the population, every student in Year 12, I might conduct a survey. I might just ask some of the students in Year 12 in the ACT. So in order that I receive accurate information, I want to avoid bias. So I'm just going to mention two types of bias. The first is interviewer bias, where the interviewer does something to yield inaccurate results. For example, if I ask the question, given that homework makes you smarter, how many hours of maths homework do you complete? I'm encouraging respondents to overestimate the amount of time they spend on homework, so I probably wouldn't get accurate results. Now, if I'm conducting a survey, I've got to make sure that my sample isn't biased. What I mean by that, I want a sample that is representative of my whole population. So, for example, I'm not just going to ask students in Year 12 who do specialist maths because they're likely to spend more time completing homework. That would be a biased sample. In order to avoid a biased sample, we want to take a random sample. We want to randomly ask Year 12 students in the ACT. So there are heaps of different ways that you can form a random sample. I'm going to mention two: cluster sampling and stratified random sampling. So cluster sampling is when you randomly choose a subgroup to ask. So for example, I could pick one school at random in the ACT and ask 100 students from that school. We just have to be a bit careful because that could lead to a biased sample as well. You know, if I just ask students at the top school in Canberra, probably not going to be representative of the whole population. So the other type of random sampling I'll mention is called stratified sampling. That's when you make sure certain groups are proportionally represented. So for example, if I know in ACT that there are 52% of students at public schools and 48% at private schools, a stratified random sample would be I ask 52 random public school kids and 48 private school kids so that I've got the same proportion of public and private schools in my sample. You know, I could also ask 104 public school kids and 96 private school kids or whatever. But random sampling is generally the best way to avoid bias. So the last thing I want to do here is explain the difference between a statistic and a parameter. So a parameter is basically something true about the population, and a statistic is true about the sample. We use statistics to infer or estimate things about the whole population. So let's go back to my example where I was interested in the amount of maths homework completed by Year 12 students in the ACT. So we might let P be the true proportion of people who spend at least 2 hours on homework. So this P is unknown. I don't actually know what proportion of students in the ACT spend at least 2 hours on homework. So how can I get an idea of what P actually is? Well, what I could do is I could come up with a statistic. I could just take a sample from the population and find out what proportion of them spend at least 2 hours on homework. So for example, let's say I survey 120 Year 12 students, 36 spend at least 2 hours completing maths homework. Then P hat, this is the sample proportion, is just 36 out of 120, which is of course equal to 0.3. So this here is a statistic. This 0.3 gives me an idea about the proportion in the true population. So how good the statistic is, how accurate this number is, depends on many things. It depends on whether the sample from which I got this data was biased. It depends on sample size. Obviously, the more people I ask about their homework habits, the more accurate my information will be, and so on. But that's what statistics are. They are just used to infer or give us information about the population, about a parameter. So in this case, the statistic statistic is the proportion of people in my sample, and the parameter is the true proportion of people in the population, which I don't know. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.